Okay, next we're going to turn our attention to pathogen removal mechanisms and pathogen credits. And to speak with us all about that today is Ufuk Erdal, who's the National Water Reuse Technical Practice Leader for AECOM in Los Angeles. Ufuk has more than 21 years of experience in planning, pilot testing, designing, and costing treatment facilities that are used in reuse applications. His expertise includes assessing and validating new technologies applicable to advanced water treatment, water reuse, concentrate treatment, and recovery. And he's authored more than 60 peer-review articles and conference and technical papers, and is co-author of 3 of the manuals of practice for the Water, Environment, and Reuse Federation. Dr. Erdal assists agencies in addressing water reuse management challenges, especially in arid, drought-prone areas, where techniques such as recovery and reuse for water storage, groundwater recharge, direct and indirect potable reuse are essential to securing a diverse water portfolio. He has a BS in Environmental Engineering from Istanbul Technical University, an MS from The Ohio State University, and a PhD in Civil Engineering from Virginia Tech. Please join me in welcoming Ufuk Erdal.
I'll change the topic today a little bit. So my topic is pathogen removal mechanism and pathogen credits in MBR-based advanced treatment facilities. So this is my outline. I'll start with the background, objectives, comparison of pathogen credit in full advanced treatment-based and MBR-based systems, MBR pathogen removal mechanisms, approaches to improve pathogen removals in MBR-based advanced treatment facilities. At the end, questions and comments. So currently, full advanced treatment consistent of RO and advanced oxidation process is the approved process train in California, certain potable reuse projects. MF is typically added in front of RO to provide adequate pretreatment for reverse osmosis facilities. This treatment train has been very effective to meet pathogen, all drinking water, primary, secondary criteria, federal and California. In addition to this, we don't see TOC in drinking water regulation. That treatment train meets less than 0.5 milligram per liter TOC. So here are the comparison. Top represent full advanced treatment facility. You can see that primary and secondary treatment, conventional activated sludge facilities can receive some credit. This is based upon Dr. Ross' study, 2004. Brian already indicated that study earlier. So, but key thing is MFUF can get 4-log crypto, 4-log GRD credit based upon direct integrity testing. That test is about 5 minutes, entire day. Based upon pass-fail, you will get that credit. But more than 23 hours, you don't see actual state of UF-MF membrane, whether fully intact or compromised. So, but still we are given credit. We are not monitoring every minute. But MBR, if you see the bottom one, MBR gets nothing till recent days. There are good news I'll share with you. Probably I already shared with some of you in the past. So State Water Board is given some credit, conditional credits. So as a result, when you add them together, RO gets about 1 to 2 log, depending upon conductivity measurements or TOC. UVAOP gets 6 log credit for Giardia, crypto, and viruses. So altogether, FET reliably meet all the requirements, but MBR has little bit shortage. When you add especially 1 to 2 log credit through RO, 7, 8 total log removal you can get with MBR-based treatment if MBR doesn't get any credit. So, due to lack of direct integrity testing and other approved methods, so till recent days, State Water Board, Brian is sitting there, doesn't acknowledge MBR system, didn't give credit toward MBR system. Several questions arises. Can we apply direct integrity testing to MBR system? One of them. Can MBR in reality achieve better pathogen removal than MFUF system used on reuse applications? What surrogate we can use to assess membrane integrity? Can MBR really deserve pathogen credit? More importantly, assume MBR does still get nothing. How can we improve pathogen credits in an MBR-based advanced treatment facility? Today, I want to try to bring some answer to all the questions I already asked. So this is very premature, sorry about that. We have very sophisticated audiences, professors, all those things. I'm sure they are doing much, much better animation. It's so simple. So one of the key removal mechanism in MBR system is size exclusion. This is 0.1 micron is absolute pore size of some membrane product, ultrafiltration product in marketplace, very commonly used in MBR application. So regardless of surface charge characteristic, if molecule is larger than absolute pore size, will retain in the MBR membrane, but smaller, if there is no charge density, can freely pass through MBR system. This is one mechanism. The second mechanism, which is really important, equally important, the first mechanism, absorption into MLSS biomass and sequential removal through together. So small charge pathogenic organism absorbed by the flock, shuttle together, they can pass the MBR membranes because of that. Third one, pore blocking. This is also so important. CH is referring carbohydrate here, large molecule, blocked pathway, so, and then small molecules come, doesn't pass through that location. So this is also a blockage. The fourth one, equally also important, reduction of effective pore size due to dynamic cake, gel layer formation over the membrane surface. So what it does is clean membrane. We clean the membrane, small molecules can pass through. But when it gets dirty, cake layer form, that same size molecule cannot pass it. So you can see those phenomena typically in drinking water application. So we are given follow credit to those systems, but we are getting nothing to those systems. So it is your judgment at the end of the day. So this last one is the self-healing mechanism. It has been proven many times. We have purposely damaged the membrane, surface scratch to you, putting some hole, big damages. But what happened is after 15 minutes, some cases even much less than 15 minutes, it healed itself. How it does? I will give you an example. Again, this is very premature. This is damaged membrane. Larger molecule is passing. But what happened is 15 minutes later, membrane heal, cake layer form, doesn't even let the small molecules pass through. So this is the mechanism. So this is direct integrity testing for what we are using in drinking water application mainly, and some reuse application using MF-UF technologies. So what it does is, again, increase the pH from inside to outside to bring pH around, the pressure between 12 and 20 psi for a moment, and pressure source isolated, and testing start, again, 5 minutes. So we observe pressure, not the pressure, over 5 minutes. So based upon that interesting formula there, we can calculate log removal values, QP, permeate flow. ALSR is air-liquid conversion ratio. This is typically calculated by the membrane supplier, but you can check it, validity of that calculation. It's so much hydraulic in it, trust me, I can share with you if you like it. P atmosphere, atmospheric pressure, delta P test, the pressure decay over 5 minutes, the average decay over 5 minutes. V system, the pressurized air volume in your system. It's not in the membrane system, include the entire plumbing. From beginning to air, start that thing, use air, accommodate that thing to very tailed end. So with this, we calculate log removal values. But I have problem with direct integrity based approach because the test pressure is relatively high, again 12 to 20 psi, and many MBR suppliers cannot accommodate that pressure because there is an internal coating in there specifically designed for wastewater application to improve productivity, permeability. You can use drinking water membrane, bring it put it in the tank, we are done. You cannot do that, sorry about that thing. So DIT test pressure will exceed most of the membrane available in the marketplace. One of the membrane, we know that, I don't want to give the commercial name, can technically do that testing because they are using drinking water membrane and they have tested and got some credit in Australia. So the problem started. Lack of correlation between direct integrity testing and the actual removal mechanism we observe in MBR system. Poor blocking, keck layer formation wasn't counted in the direct integrity testing. Presence of predator organism, they consume small organism. You can basically quantify with direct integrity testing. Absorption of the pathogen on the MLSS biomass, you can basically quantify with direct integrity testing. More importantly, there is sludge vesting also volumetric concentration factor. In drinking water, the filtration guidance manual defined that VCF is the ratio of the feed water divided by raw water. So deposition mode, filter is equal to filtrate, no recycle. So if you don't use coagulant, this is 1 because the raw water and membrane feed water equal. Let's think about MBR. MBR, we have how much TSS in the raw wastewater? 250, 300, I am fine with this. But how much in front of MBR tank? 10,000. 10,000 divided by 250, 40. Log 40 is approaching almost to 1.6. Sorry about my math. But you are already losing 1.6 because of the VCF formula. So you can use it. It's not really good approach. So we have done some testing in Nevada, and we realized that turbidity values are well correlated with the MS2 removal through MBR systems. Australians agree also that thing. We did it independently. They look for many facilities, collected the data, and come up with conclusions saying that MBR system with 95 percentile turbidity is less than 0.4 NTU, with 95 percentile flux less than 17 GFT. They basically offer 1.5 log virus, 2 log protozoa, that means crypto and giardia, and 4 log bacteria removal. So, and then again, in California, that standard is 0.2 NTU, not 0.4 NTU, even more stricter, we are meeting that requirement. So, and then another condition with membrane, nominal pore size is less than 0.1 micron. Many membrane size is in that range. With 95 percentile turbidity, equal or less than 0.3 NTU, that can even reaches 4 log giardia, 4 log crypto. So that's a really interesting research documented from several full-scale and pilot-scale testing. Now, good news, Brian is sitting there, and Brian already promised us to give MBR pathogen credit if certain condition has been met. So turbidity, less than 0.2 NTU, another operating condition. I'm sure that flux, SRT, all those things should be suitable and reasonable enough. So with this, 1.5 log virus inactivation, removal credit, 2 log crypto, 2 log giardia. So, but is it enough to meet pathogen LRVs? Because we are looking for 10, 10, 12. I'm adding the MBR credit right now. I'm still little short. At this, I cannot get reliably meet those requirements. Little bit shortage, but still, thank you very much, giving some credit toward MBR system. So what we need to do after that point? Get better pathogen credit for RO system. We can do that. Explore option to get better credit for UVAOP system and incorporate additional treatment processes if needed. It's the last reserve. So the first one is get better pathogen credit for RO system. So we are basically typically conductivity measurement is very inexpensive. And basically process performance also monitored through conductivity, measurement, salt passage, many things. So that's a good surrogate. But resolution of that method is low because you can only demonstrate up to 2 log removal through RO membrane. So you can get more than 2 log. So what we need to do, There are studies in San Diego. Brian and his firm already involved in this, Trussell Tech. So the technology is tracer. So it's basically anti-scalant, but embedded with some type of dye molecules in it. That molecules are much smaller than virus-sized particle. Very similar in terms of surface characteristic. So we can assume that it's a right surrogate for that thing. With this, the blue shows the observed MS2 removal through our system. Red is tracer, and green is based upon conductivity reading. As you can see, that tracer has 2.3 log advantages over conductivity reading. So this is under fully intact RO membrane condition. Oxidized membrane condition, the observed efficiency is still great for some reason, but under that condition, tracer gets 3.6, 3.7 log removal, whereas conductivity reading only gets around 1.1, still 2+ point log better removal with tracer than conductivity reading. Explore better pathogen credit for UVAOP. I little bit discussed that thing yesterday with Brian Bernados. I was so discouraged. So anyway, may not happen, but still, no matter what, I want to share with you, whether agree or disagree. This is, I don't want to read every detail, but State Water Board, recent regulation, even in the past, can give you up to 6 log credit for an individual process. Whether that process is RO, you can get, but UVAOP, luckily, you can get 6 log crypto, 6 log Giardia, 6 log virus removal, but you cannot exceed 6 log any given time. So here is the design. We have done several UVAOP design I want to share with you. This is design is basically accomplished to meet less than 10 nanogram per liter NDMA. In the past, there was some log removal, but no more, because there is a requirement, specific number for NDMA. So minimum 0.5 log 1,4-dioxane removal. So to achieve 0.5 log 1,4-dioxane removal, you need to apply at least 850 to 900 millijoule per square centimeter UV dose. So you can achieve that thing with single reactor. You have to put multiple reactor in series in order to deliver that much dose. So, but good thing is each reactor is operated and monitored independently. So act like a unit process to me, individual unit process. So, and then as you can see, bottom of the line show the EPA virus inactivation, crypto and Giardia inactivation for UV system. As you can see that crypto Giardia requires 22 millijoule per square centimeter dose for 4 log inactivation, very tiny. How much dose we are using in UVAOP system? 850, 900,000, sometimes even more. So this is validation testing at City of Oxnard. We designed that facility many years ago and validated. So it was previous, much, maybe 2-3 previous regulation. So that time there was requirement for NDMA 1.2 log NDMA removal and 0.5 log 1,4-dioxane removal. Anyway, but the key message is there. They have 3 chambers in series. Each has 2 reactors, so total 6 reactors. Each reactor has that many lamps. So at MS2 red dose of 115 millijoule per square centimeter, 4 log MS2 inactivation easily met. So based upon, again, calculation, we sometimes not really prove certain things, but we believe our engineering judgment calculation. We are not actually measuring distance from Earth to Moon, right? Have you ever put a tape between Earth and Moon? I don't think so. But we use engineering judgment to estimate certain things. So based upon that dose, we firmly believe that if MS2 is 4 log remove, crypto is much easier to remove UV system, at least remove by 4 log. Each reactor remove 4, we have 5 reactor due to reactors. 5 times 4, 20 log crypto Giardia inactivation, but we only get 6. So I want to also challenge, we are using certain disinfection technologies in series. UVAOP, chlorine-based UVAOP, we are discussing, hey, maybe chlorine should get credit, AOP, but the same system, right? Why we are given credit for, even though we are using one technology there and some other system? There are many, you can see the list. What I'm saying is multiple UVAOP reactors that are operated independently, monitored independently. There is no interference between each reactor, independent, like a system. So why we are not giving credit, more credit to UVAOP system? So already you are getting tired. I am tired also. Nothing has been accepted. Choose one thing, because we have seen that thing in many applications. It is 3 large applications, one of them in California, that's a shame. When design engineers like me, after MBR, some of them, some brilliant jump there saying that, well, why don't we put UF system after MBR? UF, why? Why we need to do that? So it's so expensive. So there is much simple way. This is UV disinfection, basically. Again, when you look at the dose, 22 millijoule per square centimeter is needed for 4-log. We don't need 4-log. Again, the state board was generous, gave some credit 2-log. If you look at around 2.5, 3, the dose to get crypto and GRD inactivation is about 12, 11. So we need only this, not too much doses. So a validation factor, we know that must be added to those numbers, so to understand the dose. So biggest question, where we put UV disinfection? Is it right after MBR? UV transmittance is low, so is it the option? Or should we put the UV after RO using better UV transmittance, operating at much lower doses even? So, and some said, well, if I put UV before RO, I will eliminate the biological fouling in RO system. That is completely incorrect. You need to carry a monochloramine residual to protect RO membranes against biological fouling, which have been tested in Singapore. There is no difference, literally. So anyway, so the location is up to you. You can put anywhere, but you can easily get credit, additional credit, 2.5, 3-log to meet crypto GRD requirement. So with this is my conclusion. MBR is really robust technology. Not only do the job, forget about pathogenic organism, because it's completely different. The particle size of MBR sludge much finer than conventional system, which improve, in fact, absorption capabilities of metals. Certain CECs, not every CECs though, CECs with higher octanol water partition coefficient can be absorbed, sequentially removed. You have better deal with MBR than conventional activated system. Using tracer and some other approach, you can improve RO pathogen removal credit. UVAOP may deserve better pathogen credit, but you need to discuss this with State Water Board. And UV disinfection with much less than 50 millijoule per square centimeter will give you around 2.5, 3-log easily credit to basically, if you have MBR train, you can meet your goals. With this, I am done. If you have any questions, comments, I'll be more than happy to answer. Thank you, guys.
It was really good. Thank you so much. No problem. Okay, we're running a little bit behind, so I want to take the opportunity to encourage you to go enjoy lunch. We're going to reconvene the program in about 45 minutes, and we'll go with Robert Glennon's keynote. So good luck. Sorry we don't have time for questions right now, though. Lunch is right outside the 2 doors right here. There are 2 lines. Take advantage of both. And if the last night's meal is any indication, the food's going to be really good.